This video is to show a few more examples of solving systems of equations with three unknowns. If you've watched my first video, you've already gone through the process on how to solve these. So we'll go through a few more examples just to make sure we have it down. So the first thing is, I'd pause this and copy down the system I have here. Make sure you're very careful about having the correct signs in the correct spots, because if it's not in the correct form, then you won't get the correct answer. So we got 2x plus 3y plus 5z equals 7, and I'll label that with equation 1, the Roman numeral 1, just so I can identify it. Negative x minus 4y plus 6z equals 11. I'll label that with Roman numeral 2. And then 4x plus 3y minus 2z equals negative 13. I'll label this as equation 3. So this way I can talk about them and easily refer to them. You should do this for yourself. You won't see it in any of the problems as you start them, but you should label them for yourself. The other thing is make sure, I wrote z's with lines through them, so they're z's, so I can differentiate them from 2's. You probably would want to do the same. So in order to solve a system of three equations, first off, you want them in this, standard form with the x's, the y's, the z's, the equal sign, and then the constant on the opposite side, and they all should be lined up in the same format. If they're not, the first thing you should do is line them up in the correct format. After that, you want to really take a pair of the equations and eliminate one of the variables, and then take another pair of the equations and eliminate that same variable. It doesn't matter what you pick to eliminate. Sometimes one is easier than others. I'm looking at this system, so I'm going to choose to eliminate x's. Now, you could pick to eliminate, y or z. It doesn't really matter. You'll get to the same answer in the end, but your steps will look different. So I'm going to pick to eliminate x's. And the first equations I'll use equations 1 and 2. So we have to pick a pair of equations. I'll pick to use 1 and 2. So if I want to eliminate x's, remember how this works. You want to have the same coefficient but with the opposite sign. Right now they don't have the same coefficient, but they do have the opposite sign. So when I look at this, to eliminate x's here, we really want to multiply equation 2 by something to make this look like a negative 2. So when I add it to a positive 2, it'll cancel to a 0. So in this case, we're going to multiply equation 2 by, well, what would give me a negative 2 here if I multiply this by 2? So you multiply equation 2 by 2 and add it to equation 1. And to do that, maybe I'll just write it as, this is 2 times equation 2. All right, I'm going to add it to equation 1. So if I do 2 times equation 2, maybe I'll just write what it is if you look at it up here. Here's equation 2. We're going to multiply each term in here by 2. So 2 times a negative x will be a negative 2x. 2 times a negative 4y will be a negative 8y. 2 times 6z will be a positive 12z. We have our equal sign. Don't forget to use the opposite side. 2 times 11 gives me 22. So I multiplied equation 2 by 2. I'm going to add it to equation 1, which I'm just going to write straight out as it is. So it was 2x plus 3y plus 5z equals 7. And remember, elimination is sometimes called the addition method because you add these together. When I add these, we have a negative 2x plus 2x, and those will cancel. And they should. We chose to eliminate x's, remember. So if you didn't choose to eliminate x's, something else would cancel. But here we chose to eliminate x's, so they canceled out. And then we got negative 8y plus 3y. So negative 8 plus 3 is a negative 5. The y comes along, combining those like terms. 12z plus 5z is plus 17z. And this is equal to, and then 22 plus 7 is 29. So this is our new equation, which only has 2 variables in it. So that's important because the goal is really to get 2 equations with 2 variables that are the same, so you can solve that system of two unknowns. So we have negative 5y plus 17z equals 29. I'm going to label this with letter A just so I can refer to it. Now, you eliminated x's using equations 1 and 2. The next thing you want to do is eliminate that same variable. So if I chose to eliminate x's here, I want to eliminate x's again, going back to the originals, but using a different pair of equations. So now I'll eliminate x's. You have to pick x's again because the next equation you want to have left is y's and z's. So we're going to eliminate x's, and this time I'll use, let's say, equation 2 and 3. All right, as long as you pick a different pair of equations, this will still work. So I'm picking 2 and 3. You could have also picked 1 and 3. So we're going to use 2 and 3. So we're using these two. And I want to eliminate x's. So I want the coefficient of x to be the same but have the opposite sign. So this has already got opposite signs. This is negative, this is positive. What do I multiply equation 2 by to make it look like equation 3? In terms of the x is eliminating. Well, I need to multiply by a positive 4 because negative x times a positive 4 will be a negative 4x. When I add that to a positive 4x, they'll cancel out. So what I'm going to do here is I want to multiply equation 2 by 4 and add it to equation 3. So I'm adding these together once I multiply equation 2 by 4. And remember, we're doing that because we want x's to eliminate. So I'm going to say 4 times equation 2. And we're going to add that to just equation 3 down here. And we'll see what we have. Well, 4 times equation 2 will be 4 times each term here. So 4 times negative x is negative 4x. 4 times negative 4y is negative 16y. 4 times 6z is plus 24z. And that's equal to 4 times 11. Don't forget to do it to both sides, which is 44. Equation 3, I'm not manipulating it at all because I don't have to change it. So this will stay as 4x plus 3y minus 2z equals negative 13. Remember, elimination method is sometimes called the addition method because we're going to add these together. So negative 4x plus 4x cancel out. They should. We chose to eliminate x's. And one of the reasons why I chose to eliminate x's right away is that I know the coefficient here is just a negative 1, so it's easier to manipulate with these equations rather than some of these other coefficients. But it's okay, you could pick anything. So I chose to eliminate x's, those canceled. Negative 16y plus 3y is a negative 13y. 24z minus 2z is a positive 22z. Watch your signs there. And it's equal to 44 minus 13, which equals 31. And I'll label this equation B. So now we have, once we did the eliminating of x's twice, using 2 different pairs of equations, is now we got a system of 2 equations with 2 unknowns. And we can solve this because they're the same unknowns, y and z and y and z. If you chose to eliminate x's here, but then you eliminated something different in the next step, this equation wouldn't have y's and z's, and you wouldn't be able to use these together. So that's why we did what we did. So now I want to solve this system, right, of the negative 5y plus 17z equals 29, and the negative 13y plus 22z equals 31. Well, what do I eliminate, y's or z's? It doesn't really matter what you pick. I'll pick to eliminate y's just because they have smaller coefficients, but it doesn't really change anything. So if I chose to eliminate y's here, right, we're using equation A and B now. The y's they both have negative signs, so one of these has to get multiplied by a positive, so the signs are opposite. Because remember, when you add these together, the signs have to be opposite to cancel. Now, when you see the 5 and the 13, you can't multiply 5 by anything to get to 13 very easily. You can't multiply by a whole number to get there, or an integer. So, what you really should do is take a look at 5 and 13. Think of the smallest number they both go into evenly. It's almost like finding the LCD. And if you're really not sure, you could just say, okay, multiply this by whatever this one is, multiply this one by whatever that coefficient is, and just make sure the signs are correct. So the smallest number 5 and 13 both go into is actually 65. So we're going to make these both look like 65. I'm going to multiply equation A by the negatives to make this a positive. So I'm going to multiply equation A by a negative 13. All right, so we're going to multiply A by negative 13 and multiply equation B by, all right, so negative 13 will give us a positive sign, so we can multiply this one by, this one to stay negative, so we'll just multiply it by 5. I'll say by 5. Then add them, just so you know what I did. All right, so you're going to multiply equation A by negative 13 to make that a positive 65. You're going to multiply this by a positive 5 to make this a negative 65. So the idea behind this is that you're actually multiplying by whatever the coefficient is of the opposite one. If there's not a number that's smaller, it'll work. So doing this, Right, we'll have negative 13 times A, and we'll have 5 times B. And we'll see what we get. So negative 13 times A is negative 13 times negative 5 is a positive 65y. Positive 17 times a negative 13. Let's make sure we do this here. So we got negative 13 times a positive 17. That gives us negative 221 z. And that'll be equal to 29 times negative 13. So 29 times negative 13. I get negative 377. And then we want to multiply 5 times equation B. 5 times negative 13y is negative 65y. 5 times 22z is going to be a positive 110z. You can multiply on the calculator if you're not sure. And it's equal to 5 times 31, which comes out to, I think it's 155. We can verify it quick, right? 5 times 31, it's 155. So now remember, what are we doing here? This is elimination method, so we're adding, right? Sometimes it's called addition method, and we're trying to eliminate y's. Well, 65y minus 65y, or plus a negative 65y, cancels out. Make sure those signs are opposite. If they're not, they won't cancel. Sometimes you'll make the mistake of keeping the signs the same, and they don't cancel that way. So 65y minus 65y canceled out. They should. We chose to eliminate y's. We got negative 221z plus 110z. If you want to do that, negative 221 plus 110. We get negative 111z. Don't lose your z. Is equal to negative 377 plus 155, which gives us negative 222. And now we have one equation with one unknown, so we solve this for z. So I'm going to divide both sides by negative 111. Divide by negative 111. We have z equals, the negative over negatives to make it positive. 222 divided by 111. I know that comes out to 2. You can use your calculator to get there, so we found z. Now remember, once you find z, you want to find the other variables by back substituting into either of these, and then all the way back up into either of the originals. So now we'll say from here, I'll back sub into either A or B. It doesn't really matter which one you pick. So I'll back sub into A for z equals 2, which means I'm substituting into here. So I'll have negative 5y plus 17 times 2, and that's equal to 29. So this is negative 5y plus 34. 17 times 2 is 34, equals 29. We're going to subtract 34 from each side. Got negative 5y equals 29 minus 34 is negative 5. And then we're going to divide by negative 5 and divide by negative 5. We end up with y equals negative 5 over negative 5. Well, that's a positive 1. So now we found z. We found y. So now we're going to take these and we're going to go back up to any of the originals. And we're going to try to solve for x. So now, all right, we're going to back sub to find x. And I'll do it up here just because it's easier to see. So remember, z was 2, y is 1, so we're subbing in 2 and 1. I'll back sub into the first equation. So equation 1 here. If I sub into any of these, you should get the same answer. So you would have 2 times x plus 3 times y, which is 1 we just found, plus 5 times z, which we found to be 2. We want this to be equal to 7. Right, so we're substituting into equation 1, and now we're just solving this. We got 2x plus 3 plus 5 times 2 is 10 equals 7. So we got 2x plus 3 plus 10 is plus 13 equals 7. We're going to subtract 13 from each side. So we get 2x equals 7 minus 13 is negative 6. And then we'll divide by 2. And divide by 2, and x equals, here we get negative 6 divided by 2 is negative 3. So the answer here, x, y, z, it's an ordered triple. We'll put it in alphabetical order, is negative 3, 1, 2. All right, so solution, I'll just write it here so it's easier to see. is going to be the ordered triple -3, right? That's the x value. The order matters. The y value next, and then z. It doesn't matter what order you find them in, it's always going to be x, y, z, or alphabetical. So -3, 1, 2. So -3, 1, 2. That's the solution. That's the ordered triple that would make all three of these true if you're subbing into each of them. You know, keeping in mind that when you do this, because I chose to eliminate x's first, I solve for what I got on my own. If you chose to eliminate y's or z's first, you might get the same answer. You should get the same answer, but the steps in between here will all look different. But that's okay, as long as you can get to the correct final answer. So the goal is use elimination twice at the beginning on the same variable using two different pairs of equations. Take your results from there, which should have the same two variables, and then solve that by elimination. Solve that system by elimination. You'll have one variable left. At that point, when you have the one variable left, you back sub into either of those two, and then back sub both your results back into the top three. So if you wanted to check this, a way of checking would be to make sure that this works in all three equations. If it doesn't work in all three equations, it means you made an error somewhere. I won't ask you to check it most likely, but that's how you would know. What this really means is that the solution works in all three equations. That's what makes a solution to the system.